All right, so we've already talked a bit about how significant figures only apply to measured values. For most of what we do in our actual chem class, we're measuring off of graduated cylinders. We do, however, use balances, which of course have measured values as well. You just don't have to actively measure. The digital readout tells you the actual number. And then we do use rulers and calipers sometimes, but for the most part, we're measuring in graduated cylinders. So being able to read a graduated cylinder appropriately is really important to us. We've said that significant figures are all place values known with certainty, known for sure, plus one estimated digit, one estimated place value. So in this case, in this graduated cylinder, we know for sure the tens because they're literally drawn right on the actual device itself. So it says the 90 right here, and that line falls right here. So we know for sure that that is um, the lines that are marked. Plus, we also know the ones place values because they are also drawn right on the graduated cylinder itself. So we know those for sure. There's no ifs, ands, or buts about that. That's what we know. And so if we're looking at this meniscus, which you can see you from the side here, um, we read the very most bottom portion of the meniscus right here. This top portion of the meniscus would be this part of the meniscus if you're looking at it from the other side. That's why it looks kind of like a silver bubble. We need to read the very bottom of that, and then we read our actual measurement. So we know that this is 80, this is 81, this is 82, this is 83. So the bottom of our meniscus is falling between 82 and 83. We know that for sure. So you would say it's 82 milliliters, but then it's also point something. So point zero maybe, or maybe it's point one. I wouldn't say that point two is out of line, but we're starting to get at a number that's really no longer all that great. So if we look at some other examples further down on the sheet here, we're going to see one where we have to do a bit more estimating. So now I have the benefit of being able to zoom in on the actual screen. You don't have that benefit when you're looking at an actual graduated cylinder, but getting eye level with that meniscus and getting close to it's important. So if we take a look at our actual meniscus here, um, on our device, we know for sure the 50 and we know for sure the 60. Those are of no question, which means that this right here is 55. And then this is 56. This is 57. This is 58. So we know for sure that we are at 57 point something. So for sure 57 point something. Now, what that point something is, that's where we have to estimate. So we can't have any question about the 57. That's for sure because it's between the 57 and the 58 line on the graduate cylinder. How far past that line, that's where we have a question. So 57.1 would make sense, 57.2 would make sense, 57.3 would also probably make sense. Much past that, it doesn't make sense because I'm looking right here, and right in the middle here is 57.5, and I can tell it's definitely below the 57.5. So that's how I'm getting these numbers. I can also tell that there's a little space between the bottom of the meniscus and the 57 line, so I can't say it's 57.0. That would be a bad answer. That's definitely not that because it's not right square on that line. So that's one example of this could be a 100 milliliter cylinder. That's probably what we're looking at here. Now, if we're looking at a different cylinder, um, like the one almost below it, this is definitely graduated differently because in this case we have our numbers marked as a 4 and then as a 5 right here. So we know that this is a ones place value that's known for sure, and a set of lines here that are going to be the tenths. So this is probably a 10 milliliter graduated cylinder. That's what ours look like in class. Um, so this is going to measure a little bit more accurately than the 50 or the 100 mil graduated cylinder because there's more lines and we're a skinnier piece of glass. So that's going to be a better measurement. But in this case, when we're looking at this stuff, Here's our 4. So we know for sure we're running at 4 because there's a line that says that, and our meniscus falls between the 4 and the 5. So here's the point 1, here's the point 2, here's the point 3. And since my number falls between 4.2 and 4.3, this is 4.2 for sure. There's no question about that. You can't argue that. And then as far as what that number is, this looks like it's definitely past half. So we're looking at a number that could be 4.26, maybe 4.27 is looking better. 4.28 is probably okay. You could even get away maybe with a 4.29, but definitely not 4.30 because that meniscus is clearly underneath the actual line there. And then these two are probably the better two answers as far as what we might have. So 4.27 or 4.28 are both acceptable. We know this number for sure because this one, whoopsie, that number is literally marked on the graduated cylinder. This one we know for sure as well because that's literally marked on there. This digit right here, the 100th place value, we are estimating because we're guessing what that place value is. It's a reasonable guess, but we're not 100% sure. So when you're looking at this, these other graduated cylinders on here, I'm giving you a bunch of different graduated cylinders with different ways to look at a meniscus, so you're kind of well versed. Looking at a graduated cylinder seems like it should be easy, but there's actually some level of difficulty while doing that. So it just takes some practice. So we're going to look at all of these that are on paper, practice them, please check them over with a neighbor, see how you're doing, come up with some reasonable answers, then please check your work.